Hello, we are Team Titans, and I am Trinity.
And I'm his sister Trinity.
We want to share our hobbies with other people with with nowadays technology. Here are some of our hobbies we have. For example, I like reading.
And I like swimming.
But between both of us, our shared hobby is Lego and robotics, which led us to FLL. But the problem is, what most people think when they think of Lego is Lego sets. And our grandmother even got us a Transformer Lego set when she misunderstood our hobby.
How do we ensure the people will know our hobbies better?
So first talking to mind, 3D modeling. 3D modeling is very common and to us, and we know a lot about it.
But why should we show them the pictures when we can show them the real thing?
But then after doing just one robot, I realized how hard it was to piece the robot, make the robot piece by piece. So then I thought of photogrammetry. Photogrammetry is taking pictures at different angles and making it into 3D models.
But we can't bring a laptop everywhere just to show people our hobbies. How can we make it more convenient?
Then we thought of virtual reality. Since we have a virtual reality headset at home, we know how to use it easily. But it took us some time to learn the controls, and we want to make it more accessible to other people and make it easy for them to learn the controls.
But not everyone knows how to. Not everyone knows how to play VR. When I was in the MRT, when I looked around, everyone was using their headphones.
Then we thought of switching from virtual reality to augmented reality. Augmented reality is putting virtual objects into your camera so that it looks like it's actually there. So I programmed up a software and showed it to our family and friends.
We had 32 of our friends and to try this out, and our 7-year-old cousin Isaac, who thought it was Transformers, now understood our hobby.
But then we still had some feedback and we took improvements from our friends. For example, they did not know what doing missions meant, so we told them we decided to change it so that our robot can actually do the missions inside the AR. So now it's your turn.
So you press allow, and you scan the first Lego leak box, and you can see the mat in there. When you press the mat, all the objects will appear. And you see our robot on the bottom left. When we press the spike, it will actually move to do our run tree.
Lego, and each one of them mean one core value. So this is discovery, which is the first core value. And when I first discovered Python, it was very hard for me to learn, and I thought it was very hard, and I felt like giving up. But after a while, I got used to Python, and I realized how easy it is to code Python and how efficient it is.
And this one represents teamwork. So within the team, Tim has more experience in coding and robotics than me. But sometimes he gets frustrated and feels like giving up. And I make him snacks like chocolate milk to help encourage him to continue the runs. Like in this, I'm giving him an ice cream to help him encourage him. Now you get to pick.
So this is innovation, and as you can see here, I discovered gear ratios, and because we couldn't do several missions because our motor did not have enough power. but then after looking at the parts we had, I realized that we could use gear ratios to increase the power of the motors and let us do more missions. So now this is impact. After doing our innovation project, we realized how AR, like over here, this person is on the other side becomes a ninja, can actually, how our innovation project can actually make a difference to the world by letting other people visualize AR better. Visualize our hobby better.
This one represents fun. We had a lot of fun passing our innovation to our families and friends. All of them were like, wow, how did you do it? And I was very happy we could amaze them.
Now this is inclusion. Although me and my sister are siblings, we still have some differences between each other. So I still allow her to help in the project and make sure she learns. And as you can see over here, I'm letting my sister help help in building the robot. And these are all our core values. Okay, so now we have come to our robot design section. So first thing, part of our robot, as you can see over here, we have this two gears over here so that we can modularly switch between attachments. We also have this quick release system that will switch between attachments easily. We also have medium motors over here because they have the right torque to speed ratio. We also have a light sensor at the bottom of the board to be able to sense colors and lines properly. We also have this holder on the back to be able to place people on the back to earn points at the end. So now I'm going to show you how the attachment fit. You hold the quick release system back, place the attachment in, and then push the quick release system back in. So over on the top here we have this spinning wheel. It will help spin the tower and bring it up to the correct height. We also have these small gears on the side that help spin the gears inside the chicken. We also have this small arm down here that helps hook onto many different items and helps us collect other things. But now we're going to go on to our run to attachment. So over here we have this arm that will push down this attachment like so, which will get us all our points by putting the people in place. The bad thing is that we can't collect the expert over here and somewhere near it, because it locks the whole thing. But down here we have this arm lock that will lock the mechanism when it is up, but when it's down, no, it'll unlock when the mechanism when it's up, but when it's down, it'll lock it, as shown like this. As As you can see over here, it's currently locking and it can't move out until the arm moves up and it can go out. Now we have this arm over here that has a high torque. As you see, it's a small gear to a big gear, and it can push down the mission easily. Now on to our last run attachment. We have this holder over here that will help hold the the pedestal and the expert in place as it moves it out and drops it off onto the museum. We also have this arm down up here that has high torque to be able to push the missions easily, and has a long axle to be able to flick open many different missions. We also have this small green piece over here that will be able to hook on to one of the levers in the missions. We also have this arm that goes out sideways, and to be able to push the the arm one whole round. So over here in my code, I have this timer that slowly goes faster and faster by beeping like this. Okay, we'll skip that for now. So over here we have all our code over here, and it's done in Python, which is all coded out. Over here is all the missions done separately, done by my sister. Well, I code all the base code and all the runs, which are all the missions put together. For me, I also have done a lot of testing and printing, because then we were able to see in the console when it's doing certain actions, and it's very useful. Over here, we also make a command called P instead, because of how much prints we have to use, and it's a lot more convenient to write P instead. And that's all our code for now.